Okay, machine science Olympiad students of mine, if you can't get problem number 24, let me see if I can do it. A box can be moved up an inclined plane at a constant velocity of by a force of a magnitude of F1 or down the inclined beam with a constant velocity of a force of magnitude of F2. The coefficient of kinetic friction between the box and the inclined plane. So find the coefficient of kinetic friction between the box and the inclined plane, assuming that F1 equals 6F2 and both forces are parallel with the inclined plane. The angle alpha between the inclined plane and the horizontal plane is 15 degrees. So what are we given? We're given this force of F1 pulling it up, overcoming static friction, and F2 overcoming static friction to allow it to come down. We're also given that this is 15 degrees of an inclined plane, and we're asked to find the coefficient of friction. And we're also given that F1 is equal to 6F2. So what are the forces that are involved here? And let's draw them out. So we're going to have a gravitational force causing this box to go downward. And I'm going to draw that here. And we're also going to have it over here, right? And it's going to be working with, so to speak, the F2 force and going against the F1 force. So it's going this way and it's going this way, okay? So the frictional forces go opposite of whatever direction the block is moving. So in this first diagram, the frictional force would be working this way, right? And in this diagram, since it's moving down, it would be working this way, right? Because I did this problem earlier and I screwed that up. So again, its frictional force in this diagram is working against F2, and here it's working against F1. So let's label these. So I'm going to call this F parallel because that's what the physics classroom calls it, F parallel. But also a way to think of it is the gravitational force. F parallel is basically equal to the gravitational force causing the box to slide down if there was no coefficient of friction. Gravitational force. Okay? And then the frictional force, we'll call that F mu. So here it's F mu, and here it is F mu. Okay, so let's add up these forces, and the way I think of it is if they're on the same side of the box, they're going to be on the same side of the equation. So F parallel plus F of mu is going to equal to F1. And then F parallel plus F2 is going to be equal to F of mu, or the frictional force. All right, so we have this equation up here that we can use. And I think what I'll do is I'll go ahead and solve for F2 here and say that F2 is equal to F of mu minus F of parallel. And then I'll go ahead and stick F2 in here. And so now I'm going to get, and I'm going to bring this down here, that F1 is equal to 6 times F2, and F2 is F of mu. So I'm just taking 6 times that guy and 6 times the F of parallel. Okay, so I've not got two equations, and now I'm going to go ahead and put F of 1 right here. So now I have F, set these equations equal to each other basically. F parallel plus F of mu is equal to 6 F of mu minus 6 F parallel. So why don't we go ahead, so what we were asked for is the coefficient of friction, and that's going to be in our F of mu. So let's get F of mu by itself. So we have go ahead and do algebra here. And then, so if we minus both sides by f of mu and add both sides to 6 parallel, I'm just basically doing algebra here, and I'm going to get 7f parallel, and that's going to be 0. It's going to equal to 5f mu. So I'm going to switch it around. I'm going to say 5f mu equals 7f parallel. So f of mu is equal to 7/5 f parallel. Okay? So now, what is f of mu and what's f parallel? Well, f of mu is basically, let me go over here. So f of mu is basically going to be equal to, and we'll do this in another video, but it's m times g times the cosine of theta, which is here is 15 degrees. And the f parallel is equal to m times g, times the coefficient of friction over here. So we got that guy right there. And m times g times the sine of theta, which is 15 degrees. So let's go ahead and plug these into our equations. So f mu equals m times g times the cosine of theta equals 7/5 to f parallel, which is m times g times the sine of 15 degrees. So m and g cancel out, and that's convenient because they never gave us mass in the problem, and I keep forgetting my what I'm solving for. So it's mu times mg times cosine of theta. That's what this f of mu is equal to. So I say mu, I'm going to divide both sides by cosine theta, 7/5. It's a cosine of a sine of theta, which is 15 degrees, divided by the cosine of 15 degrees. Okay, so we pull out our handy-dandy calculator and move this over so I can see it. So, and make sure you're in degrees on your calculator. So I'll take the sine of 15 and divide that by the cosine of 15, and I get 0.267, and I'm going to multiply it times 7. I'm going to divide it by 5, and I get the coefficient of friction is going to equal 0.375. 0.375, and that's my answer. And if I go back and look at the Science Olympiad test, the answer was 0.36. So I think that's the way to do it. If not, please let me know. Thanks for watching and have a good day.